Before we get started, I just want to thank everyone for taking the time tonight and join the discussion. As advertised, I am nobody, and if I can do this, I believe you can do this too. So I hope for today's 1 hour, after the hour. Hopefully, I can convince you all, like every single one of you, to try something that you've been wanting to do for a long time. So, before I jump into, explaining the journal articles I'm going to talk about and the project, I want to quickly spend few minutes or like 2 minutes to talk about one thing I ask Manus to do for me. So I am a Parkinson disease researcher. I'm working on developing biomarkers for Parkinson disease. So naturally, I'm interested in the Parkinson disease clinical trials out there. So I asked Manus, to retrieve those active trials from clinicaltrials.gov and make me a portal. I want to use this as an example. Some of you may already know that Manus itself is a agent. So there's backend, calling APIs, calling computer use protocols and things like that. But what you're seeing right now is how Manus trying to solve my request live. And on the left-hand side, I know it's not Oh, now it is. So it's thinking and executing things. And on the right-hand side, you can see it was visiting the clinicaltrials.gov website, and now it's writing some code to try to do stuff. And then, since I asked it to deploy the website, so it automatically wrote all the code to do that. And I do want to try to. Um, is it, has it been too long? Uh, I'll try one more thing. Maybe it's a permission issue. Um, so I do want to, if we are able to show you what the website looks like, because um, you know, just by giving that short prompt, as you see from the beginning, and waiting for 15 minutes, Manos was able to generate a website that looks like this, where it looks for Alzheimer's disease trials and Parkinson's disease trials, and then you can filter by, I'm interested in phase two trials. It tells you it's showing 4 out of 8 active trials right now, and then you can click the view details. It'll actually bring you to the clinicaltrial.gov website that it um, 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 used to get those information. So that's awesome, right? That's what Manos was able to do. I just want to show this as an example of, what agents are capable at this point. But, the main goal of this talk is obviously not just talking about Manos, but it's more about, implementing an agent ourselves, not just use a third-party service or anything. So when I was chatting with my friends, a lot of people that I, highly respect, and the feedback I got as far as agent and LLM is more or less like this picture that you're seeing here. They know agent or LLM, it's cute, it's great, but when they see it, they think it's full of thorns, like they want to hug it, but they don't know how. Like they always have questions about, oh, do I need to know programming? Do I need to know coding? do I need a strong, like a super powerful GPU, right? Do I have to invest like 100% or 80% of my time in order to do something? So that's a lot of the feedback I kept getting from my conversation with, again, people that I highly respect in their field. My goal is really to hopefully by the end of the hour, you'll change this whole view of this cute little hedgehog. So I won't be able to see the chat messages during the conversation. I see them popping up, but I cannot see the content. So I'll hopefully address some of the questions by the end of the talk. So I copy and paste a couple of definitions for agent, and I thought that might be a good starting point. This first one is from the Google or Kaggle 5-day intensive course that was completed last week. This last one was from the latest agent paper from leading by the Meta GPT team. It's 264 pages long and just published like last week. And as you can see, there are different ways people define agents and different perspectives. Some of them define it more um, towards um, uh, using uh, what tools it use, how it integrate different resources to achieve the goal. Others are focusing more on, more generic and just focus on the capabilities. So there are different perspectives, and I am defining agents more generic, and you can see what I mean as I move along the presentation. So I know a lot of you have already had a lot of background on large language models, but I still want to spend 10 minutes or so talking about a brief intro, brief history, um, because there are some key time points that may be relevant in terms of understanding how agent has developed all the way through how it is today. And then I want to, based on two papers. One is a 2024 paper, large language model based multi-agents. But it's a year old, and anything with AI a year is a lot. So I supplemented some of the thinkings in this 2025 paper. It's a Google paper towards an AI co-scientist. Mainly because of my background, more doing the biomedical research, and I'm interested in using that scientific as an example to show, what are some of the thinkings in how Google designed its co-scientist agents, right? And then I'll spend about 20 minutes show you a tiny little agent I implemented over the weekend. So it's a weekend project. And hopefully save some time at the end for question. So, with that, dive right in. I'm sure you all know, Transformer, right? It's the most important backend behind large language model these days. It's developed by Google DeepMind, 2017, right? And it hadn't been making big splash until, the viral success of ChatGPT in say November 2022, attracted over 100 million users in 2 months, right? But if you think about, I mean, if you are familiar with those times, the early adopters or the early days of large language models, people are really just using them for fun, more or less, right? For chats. I mean, people like use it for generating stories or creative ideas. Um, and people just more think of it as a cool thing that's out there, but not necessarily use it towards a industrial application. I mean, there's a little bit of coding and debugging assistance that's directly applicable to day-to-day work, but the point is, when you um, can someone mute, please? Yep, thanks. Um, so if you think about the framework, so basically the user put in a query, and then this black box LLM will spit out some answers, and the quality of that answer can really be variable, depends on what the query is. Um, Not long after November 2022, so around March 2023 timeframe, OpenAI introduced something called tool use. And just if you recall the example they used, is a is getting wetter. So with large language models, if you understand the concept, basically it retrieve information from the trained parameters, right? And without this tool use, it won't be able to know, okay, what is the weather today in Cary, North Carolina? So this tool basically introduced an API layer where the large language model now can call a tool that go out to get um, live, weather data. And so before you have this tool use functionality, when you ask what is the weather, there are a couple of things that may happen, right? One, it can tell you it doesn't have that data. Two, it may make something up, right? But now if you actually implemented the tool and tell it, based on this description that this tool is to get the current temperature for a given location, then LLM is able to automatically determine, okay, I need to call these tools to answer the user query. So in addition to just the query black box to response model, it adds something, called tool use. And the reason why I think, why I mentioned I define agent really generically is, if you think about this framework, this is the um, early shape of what we know as agent today, right? Like it's already using some sort of tools, and it's already not only based on the trained knowledge or parameters by itself. Okay. Um, Later on, people realize how much a large language model hallucinates. So they developed this RAG, retrieval augmented generation. I won't go into all the details about, the embeddings and vector stores and chunking and all that. Just to mention that, you have the capability of prepare some documents, right? And then you store it somehow as the knowledge for your large language model. And then when the user put in a query, it's able to query that database and retrieve all the relevant information. And then this black box LLM can digest the query as well as these documents to give you a more accurate, based on more reference based answer or response. So if you abstract this RAG, it's really, query LLM response, but then here it's interacting with some sort of vector database. And by the way, I stole this visual representation from a talk in the All Things OpenAI. I thought it was really nice visual and fits for my purpose. So I just want to give credit really quick. Um, but now that you know about RAG, I want to bring up something that was discussed or at least was fairly hot back in, I forgot whether it's late 2023 or early 2024. But people are talking about maybe we can develop some sort of system where you can have, Warren Buffett, Jobs and Bill Gates, all talking about any startup ideas you may have. And because you cannot hire them directly, how do you have them being able to discuss your ideas. So basically, what the proposal is, you can input, all their quotes, all their books, everything into a RAG. So basically, you build a Buffett RAG, right? You build a Steve Jobs RAG, and then you build a Bill Gates RAG, and then these RAGs, could all talk on a common thread. Do I have a slide? Don't have. So talk on a common thread and discuss about, the pros and cons and the feasibility of that sort of idea. But if you, abstract this out, there's already this multiple vector databases interacting with each other, and there's some form of discussion. So, if you're being loose about what the definition of agent is, this is also a early framework of agent. All right, so with that little background, I just want to talk about the two papers because these two papers really set a good foundation for me at least to understand agent. And as I introduced in the very beginning, I'm in the biomedical field and have very limited knowledge about all the AI and stuff. So reading paper has been one of the most fa one of the fastest way to get into the field. So basically, without having to spend the months or years or the hundreds of thousands of dollars other people are spending to do these research, by reading those papers, it's really an effective way to get a distilled knowledge from these brilliant minds in the world. So that's why I choose to, host this session in the form of a journal club. Um, the first paper really gives a good foundation or systematic thinking of um, all the different components when you need to design an agent. And then the second paper, you know, when we talk about that, we can sort of fit that into the system that was described in the first paper and get a better understanding. So without further ado, I'm gonna dive right into this first paper. I know some of the texts here are really tiny, and I will zoom in later slides. I just want to give you this big picture overview. Basically, this in this paper, they talked about when you're designing a multi-agent systems. There are a couple of factors you need to think about. One is the agent environment interface. Two is, when you have multiple agent, what are the roles for each one of them? And then the third one is how these agents communicate with each other. And then the fourth one is whether these agents can acquire additional capabilities or, gradually improve their capabilities and how to do that. So we'll jump into each sections by itself. Um, First one is agent environment interface. So this one defines basically how the agent interacts with and perceive the environment. So if you think about a robotics in example, right? It's able to sense the environment. So if you think about the Unitree, I don't know how much you if you have seen the YouTube or TikTok video on Unitree robotics. So basically, in that video, the blogger asked the Unitree robotics to crack open an egg into a bowl. And if you watch that video, you know that the human-shaped robots cannot quite do that yet. But the point is, it's able to perform those actions and see the result. Oh, I dropped the egg to the ground. And with that layer of interaction with the physical environment, it's able to potentially make improvements to the next attempt and things like that. So that would be a an example for have interaction with the physical environment. There are also other agents that can, interact with Minecraft or, build a new world or has the capability of writing and executing programming code. Well, you may want it to execute that in a Docker environment. So these are the many examples of different environment the agent can have access to. And sometimes you can have an agent system that just doesn't have any environment. Say for example, if you ask two agents, like the example we talked about, the Buffett, Jobs, and um, Bill Gates, discussing about the startup idea. They're really just debating against each other. They're not interfering with any physical or computing environment. So there could be no environment. But the point that the authors are trying to make is when we are designing an agent system, it's important to think about what is this layer of agent environment interface. And as I mentioned in the beginning, since this is a 2024 paper, there are numerous subsequent studies looking at other aspects. So again, leveraged large language model. I asked, what are some of the recent progress? So, and the summary was, it's pretty much focused on multimodal environment. So instead of taking, one source of data, a single source of data, it can process, multiple, image and text, for example, at the same time, and have that level of interface altogether. All right. Um, I know there may be questions. I'll try to get to them at the end. Or, if you have burning questions, feel free to open up your mic and ask them. This is not meant to be a formal presentation. It's more discussion and sharing of what's available out there and things like that. So we'll move on to agent roles. As mentioned, so when we design an agent system, those are some of the things we need to think about. It doesn't have to be that we define the role for every single agent. That's one of the possibilities, which, as you see here, it's predefined. You can have each single one of your agent has a very definitive role. But then you can also ask the, say for example, a smart agent, right? Like a LLM to generate the role of the agent by itself. Or, you can based on your data and um, um, make judgment calls that way. Um, again, attempted to supplement some of the recent advancements. They're talking about, I think, social, yeah, personalized agent, and then talked about um, uh, uh, the evolution of roles, like when you can have a role defined in the beginning, but as the agent sees the task and executes the task, maybe there are ways for the role of each agent to evolve over time. Um, right. And the third component the author mentioned was agent communication. Um, so they mentioned communication structures and content and things like that. Instead of looking at the text, I thought one of the image in the paper is more straightforward for us to understand. So basically, you can have, more sequential or layered flow of information, right? You have a couple of agent in the first layer executing their job and then pass information to the second layer, things like that. In some cases, you may have decentralized agent. Everyone is talking to each other, and each one of them is doing some sort of job. But in other cases, they may be, contributing to a common message pool, like the example we talked about the, startup ideas. Or you can have one smart agent, right? Like one LLM-based agent that's really defining or controlling, all the other agents, and there may be some so basically all the communication and all the roles are defined by a centralized agent. So those are all the possible communication styles. So really it depends on, what the goal is, what we're trying to achieve, and what makes the most sense that we can define, how we want our agents or multiple agents to communicate with each other. Lastly, Iona, the authors talked about agent capability acquisition. So basically, whether the agent is able to evolve their capabilities. And in the paper, they talked about the types of feedbacks. We gave the example of robotics. Crack open act, right? It's taking the environment feedbacks. But then you can also have one agent reviewing the work of other agents and provide feedback that way and try to improve the agent capabilities with some sort of reward system. Or you can have memories and the agent just try to evolve by itself. But this area is really active only after, um, maybe close to when this paper was published or after this paper was published. So there's a lot of research on, potentially you can train a smaller scale, language model or agent model just to control the overall flow of the workflow. So basically, you can, based on training data of how the historically your agents are achieving the goal of the user and the system, and then basically train some sort of deep learning models so that the agent, the quote unquote smart agent, are able to give better directions, so acquire their capabilities that way. And there's also other um, uh, recent advancements. I'm not gonna go into everything into detail. Um, so I thought that's a really nice way of thinking, at least, or a system that when we think about designing multiple agents, we can put our thinking into this design frameworks. So I again put it back into this visual framework when the user put in a query, right? Instead of the LLM just spits out the response, it actually rely on, all your multiple agents and how they interacted with each other and how it interact with the environment and how it interact with human during the process, and then spits out their response, right? So, now let's move on to the second paper where it's talking about Google AI co-scientist. So the system is only beta testing yet, so it's not fully available to researchers. But they documented all their procedures very clearly in this paper. So I thought it's a good reference for us to see how others are doing implementing these agent systems and basically learn from it. So this gives you the overview of what AI co-scientists look like. So obviously, there's the scientists who come up with the initial research goals and then put that into the system. And then the agent system has multiple components, which I'll go over in the next slide. But basically, excuse me, the agents will have the capabilities to use some tools, and it will have access to some defined memories. Say, for example, vector databases or already published research papers or anything along those lines. I remember they have the capability of asking or interacting with the research scientist during the process. I couldn't find where they draw it on this visualization right at this moment. But basically, after it does all the quote unquote thinking in this agent system, it can spit out some sort of research proposals or hypotheses or anything the research scientist may be interested in. So let's dive into how they really define the agent system and make this all happen. So uh, for most importantly, they have the supervisor agent. So basically, it will tell, it will monitor where we are right now, what's the next steps, who should do what next, and all those things. So this is what I've been calling smart agent to this point, right? And then it will have multiple agents, each have their own roles. You have the generation agents, right? You can explore some literatures and come up with hypotheses or ideas, and then you can pump those into reflection agents to evaluate, how these, which one's better, which one's worse. You can pump them into proximity agents to see if, many of your of the hypotheses or ideas generated by this generation agents are actually similar to each other. Um, uh, and after reflection, you may have a ranking of which hypothesis is the best, and then it can evolve, basically iterate on itself and trying to enhance the quality that way. So as you can see in this little diagram, the direction of the arrow is not really defined a process, right? Like we generate first and, proximity next and reflection third. It doesn't, always follow that, right? So a lot of, when the user has a research goal, what's the next step? Whether I should go to a reflection agent or whether I should go to a meta proximity agent is really defined by this supervisor agent. Um, so perhaps this illustrate a more complex and more and a smarter multi-agent system. Okay. Um, so this paper is rather long, but we won't go over everything because a lot of the paper was talking about how awesome they are, how they generated three hypotheses, which including like drug repurposing hypotheses, identify novel targets, and also some gene transfer mechanism explanations, and how they leveraged experimental validation or domain expertise to validate these agent generated research hypotheses. So basically talking about how awesome this system is, which I'm not going to talk about today, but there's a lot of good stuff in there, especially for if you're in this field. So feel free, definitely check out if you're interested. I do want to post one screenshot. I mean, they gave very detailed explanations on how they design their agents and what are the prompts within each steps. But I want to show one as an example, this reflection agent. Um, so what it is, it's really just a bunch of prompt, right? Like something we're very familiar with. You're an expert in yada yada, and here's your instructions, and you need to scoring. Here are the scoring criterias, and then of course you need to give the actual articles and hypotheses and responses and things like that. But this is the overarching structure, what each of the agent will look like. It's basically a bunch of, prompting tags and some passed in parameters and things like that. Right, and as I mentioned, they have very detailed implementation for each of their agent. So feel free to check out how they implement it. Um, so I just, take that and put into the same framework. So when the scientist has a query, right, the LLM can now actually rely on this smart agent to make decisions on, which goes where, and after all those reflections and improvements and evolutions, it kicks back yeah, here's the additional feedback I was talking about. It kicks back some sort of hypothesis, response to the user. All right. So to this point, we've talked about, the simplest form of, agent, RAG or tool use, right? We talked about use multiple agents and, discuss on a main thread. Oops, sorry. Uh, where is it? Here. Right, we talked about using multi-agent system and have multiple agents collaborate with each other, and then we also talked about this recent concept of smart agent where you have like agent actually based on large language models to direct other agents, right? Of course, as you go through the spectrum, you get smarter, more powerful, more flexible agent systems. But my question is, where should I start? Should I start to implement the best and the most awesome agent systems? Well, It a lot of times, when you think about smarter and more powerful, it also comes with, consequences, right? One, you need to design a more complex system, there may be higher learning curves, and most importantly, these systems are more prone to premature terminations and, their performance becomes iffy. I'm gonna again, because Manos is just so awesome, and I showed one example in the beginning. I want to go back um, to oops, to one of the examples where it actually failed me quite miserably. Where's my Chrome? Um, yeah, must be this one. Um, So one of the tasks I wanted to do was to upscale my blurry image, and trying to make the resolution better. And you can see what it, come up by the end. At least I'm not very happy with this image. I'd rather, post my initial image in the beginning. So there are also cases where it'll terminate prematurely and think that the task has been completed. So when you rely on something smart, something hallucinate to be your decision maker. You're implicitly adding that sort of variability to the ultimate performance of your entire system. Now, then, where do I start? The answer, my answer is I don't know. It really depends on your use case, right? And on top of that, there's also the complication of, right now there's a lot of agentic framework out there. Which one should I choose, right? Should I go with long chain or autogen or, you know, I actually post this. I don't know if Professor Liu, Paul Liu, is here. I actually asked this question to him the other day, and I got zero response. But I thought, zero response was a form of response because just pick one, they're all evolving and they're all gaining new capabilities. Just pick one. And they're all pretty good. Um, but if you don't buy that answer and you really want some guidelines on how to choose, so here are something that's sort of generated guidelines and based on all those comparisons that's available online that LLM was able to put together. So if you have a simple, more streamlined, step one, step two, all the way through your last step, maybe you want to consider something like LongChain. If you want to develop a multi-agent system, you have a little bit of complex workflow, you might want to consider AutoGen or CrewAI, right? If you have a domain-specific workflow, for example, a DevOps, you want to do like programming or things like that, maybe you consider a domain-specific agent like MetaGPT, right? If you have open-ended and more exploratory workflow, there's the Baby AGI available for you. And then if you're developing something for, like, say, for the company, and if stability and maintenance is really the top one priority, maybe you can look at Crew AI, Autogen, Longchain. That's just a guideline. As I mentioned, they're all evolving like every single day. A lot of these are open source community efforts, and they have a lot of improvements. Um, so don't quote me on, any of the recommendations. Uh, um, so with that, I want to show an agent I developed. It's a weekend project. I was planning, to spend a couple of weekends for it, but to my surprise, I was able to do it in 2 to 3 hours. And, because of that experience, I really want to describe the whole process, how I was able to achieve this goal. And again, the goal is really to encourage all of you who still see that agent as a little hedgehog, full of thorns, into something that's more practical and something you can try like after the session today. So the specific agentic workflow I want to do is, because there are so many AI papers published to archive every day. For example, for today, you have what was this today? Um, April 4th. You have what, 700 or no, 114 entries for April 4th. And then April 3rd, you have 111 entries, right? There's no way any single person can read 100 papers every day, right? So I want a agent system that can automatically download all the data, analyze, based on the domain area that I'm most interested in, whether that paper fits into one of those areas. And then, based on how much they contributed to the each specific area, I want to in an agent to evaluate how good is this paper, and then, give it a give it a score so that, maybe among the hundred something papers, they can choose the top 10 or top two or maybe the best one to read about it. So some of you may already picture this in your head. So you have some agent to download the data, you have some agent to, summarize the main concept of this paper, right? You have one agent that, categorize them into different categories, and then, you have one agent evaluating, right? In reality, I did not draw this workflow. How I did it was, I asked, um, where is it? Oh, I should come prepared. I asked this agent workflow. I asked this ChatGPT to design. This is the exact prompt I put in to ChatGPT, right? Deep research, that is. And then, it's asking me some follow-up questions, but then it gives me a lot of suggestions on how to design such systems. Um, I'm lazy. Um, I believe some of you may be as well. So I just copy and paste all the design considerations into Claude. Where is it? Give me one second. This, right? I just put it into, you see how the different capabilities and how the different agents ChatGPT was designing for me. So I basically inputted every single word into Claude. And then I turn on the, where is it? There's a um, deep think model, normally extended thinking model, right? Turn on that extended thinking, and then it's off to work for me. So the architecture I just showed is actually automatically generated by Claude, based on, all my prompt. And this prompt is obviously from ChatGPT design. And then it not only gives me the system architecture, it also gives me all the code that implements it, thousands of lines of code it wrote. So what I did was I copy and paste all these code based on the um, explanation. It tells me, put all these files into these sort of directory structures, and then how you install dependencies and, all those stuff, and run, right? It has step-by-step guide. I just follow that. And when I have questions, I have problems, of course, I just paste the error message directly back into Claude, and it was able to fix everything for me. Um, just to make it, more entertaining, I'm actually gonna show you real time what it looks like. Give me 1 second. So I have a Linux box at home. So this is connecting into my Linux machine. And can I make this larger? Yes. Um, so if you go to uh, archive. Um, yeah, I was able to do a number of different experiment with the system that just let vibe coding, right? Vibe coding or let LLM to code for you and implement some small features. And anyways, calm down. What was my environment? Um, activate. Should be archive. Archive. All right. So what I'm able to do is basically run a demo. So hopefully it works. So you can see the downloading agent is, accessing recent publications through these URL, and this URL is generated by LLM itself. It got a lot of results, and it's only downloading the first 100 of them, or for demo, it's only downloading five of them. So you can see it's able to get the title, the authors, and um, um, and it's in the AI category, and then the abstract, right? And then it's actually an agent extracting the question is trying to answer all the main methods, all the key uh, innovations, main results, right? It's extracting all these information dynamically using code that it wrote from the paper it downloaded, so that it's not too long for LM to be able to process it. So with this little summary, then the categorizing agent is categorizing it to Gen AI applications, right? And then an evaluation agent is evaluating, I'm giving it 8 out of 10 because of pros and cons and things like that. So, I won't go into all the details, but basically it shows that, just with vibe coding, I was able to implement something um, like this and, without a lot of effort. Um, and let me go back to the slide deck. Yeah, I have, you know, published all the code to GitHub. So feel free to check out if you're interested. You can see because I spent so little time, developing this agent. I thought I was gonna spend a couple of weekends, but it only took me 2, 3 hours. That's how powerful LLM are these days. And I didn't even bother to give it a name. I just say an agent. Right. Um, so hopefully by this point, I've been able to convince you that, this agent is not really a wild porcupine or wild hedgehog that's out there. It's really a plush animal that, anyone can just cuddle and enjoy and, just try it out. Um, Before I take questions, I do have a video of how Claude is writing all those code. So I'll play that when I open up for questions. But just to um, end the talk by advertising a little bit. So we are Research Triangle AI Society. There are a couple of main components. We're a group of people who's really into learning AI, and none of us are like or we have advisors who are AI researchers and experts, but a lot of us are just AI users and just trying to learn all the latest and greatest and apply it to our daily work. So we have organized a number of seminars and conferences. You can find us on WeChat, YouTube, X, um, you know, and this is our website. We also have a branch that's looking into robotics. We look at robotic operating systems and how agents could be used um, in robotics. But this is a membership program, so there's a uh, minimal cost to join this robotics program. But we also have a K through 12 um, educational group where it's also a free WeChat group where we will be sharing a lot of the learning resources that we think that's appropriate for youth to see. So if you want to either join the big research or WeChat group for seminars and conference, or if you want to join this K through 12 specifically for your kids, please add our president with this QR code. And if you're happy to, chat with me and follow up with your agent ideas, or if you have questions that you don't want to ask openly in this forum, you can add my WeChat here. And then we have a AI conference coming up April 19th. I believe the seating is very limited. We can invite our president to talk more about it. But you can see a spectacular list of speakers. We have professors from NC State universities. We have AG2 Autogen agent founder from Google DeepMind, and we have a number of panelists. It's only going to be 2 hours meeting, so it's very compact and very dense. So if you think about the signal to noise ratio, there's going to be a lot of signal, but only a little bit of noise here and there, right? It's really worth it. I don't know if we still have spots available, but if you're interested, definitely reserve your spot through this QR code. With that, I will start playing this just so that you can see how I just sit there and watch Claude implemented the whole thing that I showed you. Um, and it just magically worked. And with that, I'll take questions. Let's see. Is there any doesn't right? What does agent really mean? Yeah. Right. What does agent really mean? So agent comes from I don't know the origin, but in Chinese people call it 智能体. Um, so agent, there's a couple of definitions. So I think in a lot of the people's visions, these agent will be the proxy for a individual or a company in the future. So basically, I can have my agent go out to advertise for me, to talk to other agents about what I know and what I don't know, things like that. Um, uh, but I gave a couple of definitions up front of how people have attempt to explain what an agent is. Some of them think of it as LLM plus tools, right? Some of them just think of them, what are they capable of doing. So it's really loose um, definition, in my opinion. That's why I keep it loose in the first place. Um, but I welcome, inputs or discussions. Do you
Yeah,
have?
so someone has a question about minus and the ChatGPT.
Yeah. Um, I have for my tasks. Um, so this is where I really want to encourage everyone to just try it out. Right, manuals, I mean, you have to wait for invitation code and register for it, and there's little bit of starting credit, and then you need to sign on for like a monthly 40 or $200 monthly subscription. But just think about the time, it can save you. I'd say it's really worth it. Um, which one's better? They each have their um, expertise. Um, so Manus is better in doing something, right? If you want the agent to carry out some tasks for you, for example, implement a system or crop a video, right? Do things like that. Manus is probably better. But if you want to get a holistic view of a domain, um, wild ideas. I always have wild ideas. Um, in one instance, I asked it to estimate the total, the fair trading price for NVIDIA, right? Because of recent tariffs, NVIDIA has dropped from 150 to $100, and I wonder if it's a good time to buy. So, I asked ChatGPT to, give me an estimate. I mean, whether you decide to trust it, that's your decision, right? But these are the type of things that ChatGPT may be better at over Manus, whereas Manus, where is it? Is like like I asked the same thing, but it gives me a bunch of you know yeah, still give me some numbers, but like if you look into the specific process, how they derive that value, it's a lot of uh, scripts and parsing of limited data. So yeah, it like for your task, you really need to try it out. Um, and see which one's better. I'd say, each has its advantages and, knowing when to use what is ma is important. Mm, right. How do you evaluate the work of, right? Um, that's a good question. Um, there's I attended a AI conference earlier last month called All Things Open AI conference. There's a specific session for evaluation, and um, it really depends on your task. But as you pointed out, evaluation is really important. It's especially when you're developing for a industry grade solution. I mean, people are seeing a lot of failures on how unstable they are, and um, just like the picture I showed, right? How powerful do you want your system to be, right? Like if you are only using RAG and consider that as your agent, I mean, sure, it has access to some sort of vector database. So, in loose definition, that's a form of simple and naive agent. But here you can achieve, I'd say like 99 point something percent accuracy and only have slightly hallucination. Whereas if you're, implementing a system that's all the way on the other end of the spectrum, then get ready for all kinds of random stuff happening to your system, and evaluation becomes really important. And how to evaluate really depends on the specific objectives. Claude has free versions. The version I use is not free. So if you want to don't quote me on this because they keep changing. But at the time I sign up the service plan, if you want to turn on this extended thinking, it's not free. But they might have changed that to a few tr attempts every month or whatever. I'm not 100% sure. Oh, yeah. Thanks. You already explained that. All right. I'm gonna stop sharing. So whoever wants to ask a question, feel free to just ask directly in the chat or turn on your mic. But either way, thank you for joining, and I wish that was an informative hour, and I really wish by the end of the hour, either you or someone in your home, your kids, or whoever, can really make use of agents and the system. Because if you think about it, like it really gives you an edge, very over your peers, very fast. Um, got question about could you build RAG in your Claude process? Could you build RAG in your Claude process? You probably can. I have not tried. But there are a lot of systems building RAGs, and the difficulty of building RAG is not with implementing it itself. The difficulty, or at least the design thinking that you need to, oh, I was not sharing. Give me 1 second. Uh, Zoom, share. Yeah, the difficulty with building a rack system is really how you decide, how large your chunking is and how you refer back to the specific chunks in your final results. So those requires a little bit of trial and error there for sure. And also, how you choose your database designs, whether you use a traditional vector database or you use more recent graph database. There's a lot of decision thinking that goes into building a RAG. So the technique itself is very mature, and there's already drag and drop solutions out there that you don't need to really code it up. But there's a lot of fine details that you need to try it out and figure out for your solution, basically. Right. I saw more chats. Where do I see them? Um, among all AI providers, if you want to, which one is the best to use for considering cost and reliability? Ha 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 ha. Um, APIs. It's very context dependent. Um, if you ask that questions, right. This is really just personal preference. At least, I won't, advertise for one versus the other, but based on my personal use, I use them differently for different situations, right? Gemini, since the release of 2.5, has improved a lot in its capability, and I have always loved Gemini for its long context length. So Gemini can take in 2 million tokens. for Gemini 2.5, and a lot of other APIs are still limiting to 128K tokens. So when your input length is limited, especially when you're developing agent systems, you gradually lose, like if you have a long chain of thought, right, like long steps that it's executing and carry on all those messages in the prompts, gradually you lose some of the early ones. So that's the advantage of Gemini. And then Claude, in my opinion, is the best for coding. Like there's a lot claim that they're better or as good as Claude, but so far my experience has been for coding, Claude is the king. Um, and OpenAI, just for general, like I used OpenAI for my little agent. That's just for simplicity. Just I already have credits in the account and convenience. But I use their chat service a lot more. Like the um, if you think about it, their deep research functionality is a agent system, right? It's able to take your input and do thinking, do queries, do visiting websites, digest those information. So this by itself is a agent system. So I use this more often than APIs. ChatGPT has that, super expensive O1 Pro API that was supposed to be great. Make the least mistakes because I believe they do every task like 4 times and only give back your response if three out of four agrees among each other. Um, but because of the price, I have not really tried myself. And Llama just dropped, 4, right? Llama 4, and it was able to process what, I couldn't remember, 50 million or 500 million, some crazy length context uh, input token. So, maybe that can become a um, good solution in the future.